Hello, I'm Bill Dunny here, and I want to talk about how you can systematically performance tune your Android application. You can contact me at wdunny.com if you have any questions or anything you need help with. So first, I want to talk about some key strategies. Basically, there's four major strategies to performance tuning your application, and they are firstly to reduce layout depth. Uh, the more depth, the more effort it takes to draw. The second major topic is reduce overdraw, which is essentially drawing the same thing more than once when you don't have to. The third major topic is don't block the UI thread, which basically means don't do long running operations on the UI thread. And the fourth major topic is don't make excess garbage, because garbage collecting is quite slow and can cause a good amount of jank. So to help teach these topics, what I've done is created an open source application that will allow us to go through and look for these sort of issues. And first, I just want to kind of show it and give like a quick overview of the source. So this is actually an extension of the talk I did at Google I/O. So it's just kind of the same sample app, and I added a bunch to it. So this is just a simple Twitch TV client, and it's basically going out, getting the list of top channels, and rendering them, and then it shows the name of the channel. It has a little new flag where I think I said if it's only been online for less than 2 hours, I show a new flag. So that's not an API. I got to kind of figure out the logic to do that. The title, and then I also do, if it's a game, then I show this little game badge here. And it is paging, infinite scrolling, sort of a deal. It uses Picasso to download the images, so we're not really going to talk about image handling. And that's kind of it. So that's kind of your sample app here. And you can see it's, and we are in the simulator here, but it's pretty choppy. So kind of the rest of this talk is how do we systematically go about making this smooth. So, but that's it. So it's a fairly simple application. So I just want to kind of give an overview of the code. I guess I'll start with the resources. So really the only thing of interest in here is there's two layouts. You got the main layout, and all it really does, clicked the wrong tab. All the main layout really does is just a grid view and a loading progress bar. Pretty simple. The grid item's a little more complex, as you'd expect. It should be. Yeah, it's not Eclipse. This is Android Studio. But I made the colors horrible so that they show up better on the projector. So this is a little more complicated view, but I mean, you saw what it looked like. So you got a couple frame layouts stacked. It's a little deep, as you can already see. So that's kind of your layouts. Not a whole lot going on. Source code also doesn't have a whole lot going on. There's a height matches with ImageView, which, as you can kind of guess, just makes a square view effectively. I don't want to go into how that works. There's a web downloader that all it does is take, you just give it a URL and it just downloads it to a string. So super simple. You wouldn't want to use this in production code, but just super simple downloader. Model class is super simple. These are auto-generated files that just map to the Twitch TV data coming back. So it auto-parses these using these files. So they're not really of interest either. So the only two files that really kind of matter in here, there's a main activity, and it's fairly straightforward. It has, basically it's just going to get that grid view and create it, bind your data to it. When you click on an item, it actually will open the Twitch TV URL. So if you have the Twitch TV app installed, it'll run the thing, or it'll just open in a web browser. On resume, it auto downloads the first page of data. If it hasn't done it yet, it does state savey stuff, so when you rotate, it actually won't re-download. So kind of like normal best practices. I did infinite scroll stuff using the scroll, scroll listener. So when you get towards the bottom of the page, it'll start downloading more. And really, there's just this one download method that takes a page number. It hits the URL with an offset of the page number. Pretty straightforward. When it comes back, it uses JSON to parse it, which is it uses those basic data types, so it'll just parse it on the fly. It adds them all, notifies the data changed, hides the progress bar. So pretty simple. Not a whole lot going on here. And then the only other thing of interest is the adapter, which looks pretty common. You got your get view method where it's going to do your holder. It's going to get all your views, just basic adapter here, right? Get all your views. It does this little wonkiness with this stream new because that's how I was showing that new badge. So I have a little method here to do some date math to see if I think it's new or not. Uses Picasa to load the images. So you have the main picture and the thumbnail pic, and then just your holder class. So pretty straightforward. I mean, at first glance, it seems like a reasonable implementation, but I can tell you it's riddled with issues, some of which are more obvious than others. So kind of the first thing I want to talk about is reducing layout depth, because that's like far and away the worst thing you can do. So to do that, what I'm going to do is use the tools. So in Android Studio, you click this little guy.
So the layout depth thing is just because you encountered it before and you found the best performance from changes from
Layout depth, and they recommend it as well. But high layout depth is extremely hard. I think it's actually exponentially harder for each further down you go. So like if you have a frame layout with a linear layout, getting rid of this can be like almost like a 2x increase in performance, because it actually has to like keep measuring back and up and down the chain. So you really want to get those depths as flat as possible. Like if you're 4, 5, 6 deep, you're going to have a nightmare no matter what you do. Yeah, it's going to be bad no matter what you do, even if it's all simple views, right? Just because it's going to have to remeasure each of those things a dozen times. And that's when you'll go and you'll look at the code and it'll be, why did onMeasure on my text view get called 1,000 times for one rendering? And that's why. So what this will help you do is visualize it. So what you can do is come in here and you want hierarchy viewer. And this works the same way in Eclipse. You just launch it a little differently.
Can you make that any bigger by chance?
This screen, I don't think so.
Okay, that's fine.
Are these tiny? Yeah, I don't think I have zoom control on this screen. But hierarchy viewer, what you do basically, and in case you don't know, it'll work on the simulator. To get it to work on your app, you have to download this third-party library that I think Jake Wharton wrote, or one of the Android guys, and embed it, a jar file, into your class that you only want to run when you're in like debug mode. So what you do is come in here, you double click on the guy, and now here's where the patience part kicks in, because you'll generally think it's broken right now, which it sort of is, but it just takes 20, 30 seconds to grab it sometimes. And it's always, for me, been sort of unreliable. You'll notice when we're using it, it's not the most reliable thing in the world. But so basically the way this guy works, and you use this for a few things, is you can zoom in and out on this main tab here. You can do Command 2-finger if you're on a laptop. And you can drag it around. Here's like your big picture view over here, so you can drag that around. And so that's rendering this screen that we're looking at right here. What you can do as well, you can get the big picture view looking at it like this. And don't expect these to be legible. They're not legible for me either. You have to zoom way in to be able to actually see anything. So what I usually do is kind of come to the tree over here, and then you can click in, and here's where it gets kind of wonky. So it should show a screenshot here of the view. Sometimes it downloads after a few seconds, sometimes it never downloads. So there it goes. So that is like the rendering of that. So that is the grid view and everything beneath it, right?
It shows you on the right too, the right looking.
Yeah, it shows you also where you're looking. So, and you should be able to, though it doesn't seem to always work, to double click it or click on this button. There we go. So I think you click that button, and it gives you the full screen, and it gives you this on black on white, which just lets you, it puts a background underneath all this, and you can toggle it black white, which I'll come back to later. So basically what you can see here is your view depth, and each of these is going to be like one get view basically, right? So it's kind of a mess. And you can see you have linear layouts with linear layouts. So right here, if you're looking at this here, you got text view, linear layout. That could probably be a relative layout just looking at it. It seems excessive to have this double wrapped down here. So basically kind of what I did at this point is I went to the source code, and I'm not going to do it real time, but if you look at it, that's this linear layout here with textview, linear layout, and I just kind of refactor this. So what you can do is refactor that. So now there we go. Now we have one relative layout and it's flat. And I won't usually measure these. Usually I'll just, the first thing I do is just kind of use the app on an average phone, look for things that aren't performant. Generally it's only an issue with things that are based on list view or grid view or adapter view based stuff. So that's really where you want to spend your time optimizing. And the first thing I always do, I usually don't even look at the performance, I'll just optimize the layout depth because it's such a huge overall issue. So that will, there we go. So it's running the new one, and you could recapture, and where did my capture window go? Okay. This guy, I have not figured out how to reset that thing, so I usually just reopen it. I'll give that a second to go.
Usually work, but
Yeah, it's a mess. So okay, so now if you look, this looks a lot nicer already. So we just lost a whole branch of the tree, which is nice. So the next thing you really kind of want to look at is, and it kind of goes back to the slides, is reducing overdraw. So you're going to use Hierarchy Viewer again for this, but also to help diagnose it, you're going to use the tools built in here. I don't know how, you probably mostly use these, but I'll go through it. So go to Settings, go to Developer Options, which I did click, although it clicked Accessibility. Oh my god, you're slow. What is it? I didn't miss. Let's click under it. Alright, we're just gonna, what the hell? Oh my god, let's just, is everything, why is it doing this? It has to be a dick. I'm just gonna reboot. I'm gonna reboot the simulator. It was working fine last night when I did it. Let's just give it another reboot. But I can talk to it at least. So basically what you do is you're going to enable the overdraw, and I'll walk you through it in a second, but I can explain the way it works. So if you don't have any overdraw, it just looks normal. If you have one overdraw, then your image turns blue. It has like a blue tint. If you have two, it's green. If you have three, it's light red. And if you have 4+, it's dark red. And kind of the gist of it is most of your content is probably going to have one overdraw, because usually you have some sort of a background and then some content on top of it. So one overdraw is kind of normal. Sometimes you can get rid of that, but it's somewhat rare. Like if you don't have a list view and you're just like hand laying stuff out with a linear layout or something, you shouldn't need any overdraw. You shouldn't really ever want to see dark red. You should never see dark red. Light red's okay, but you should really only ever see it right on the edges of text because it's drawing those little text shadows and whatnot. If you're seeing light red anywhere else, you're probably doing it wrong, and you can probably get it better. So let me just going. All right. There we go. So here it is. So show GPU overdraw. In KitKat, it's actually buried under a new menu. It's a little confusing. And it has a bunch of new options that I don't know what they all mean yet. So usually you have to kill your app and reopen it if it's already open for this to work. So you run your app, and you can actually see the transparency. So now you look at the app and it's, oh, everything's bright red. So that means I'm doing 4 overdraws plus, which is terrible. So that's going to be really bad performance. So the most common mistake, I'd say 90% of the time, what's causing this is you're drawing backgrounds you don't need to. So like you always have the window background that you get for free with your theme, which in my case is white, which is what I want in the first place. You want to be careful setting that to transparent. If you do it, you got to do it in code because there's some issues with older phones. But sometimes you want it to be transparent because you know you're overlaying it. So basically the way you can debug this is either you can just walk through the XML, which in this case is only 2 files. It's probably not unreasonable. But sometimes you're like 5 files deep, and that's sort of not the best approach. So you can actually use the hierarchy viewer for this. And I guess it disconnected my window. I think there is a refresh.
Just to the right.
I think I gotta close it. Redo it. So I said that it's always buggy, and if you're on a phone, you usually have to plug it out and in when you open that tab. So let me let this fetch it. And I'm bringing these 2 up first because they're usually the biggest issues you'll find. The CPU issues are usually prevalent, but not as dramatic as it increases you'll get as fixing these 2 things. So okay, so here's the other way to approach this. So we come in here, frame layouts like our beginning view. Let's start with the grid layout. So I'm gonna click on it. I'm gonna hopefully let it load. There it goes. Okay. So and then I should be able to click this little guy to get it full screen. Or it's double click. I can never. Yeah, there we go. So we know our background's white from the window because that's our theme. So in this case, like I'm clicking black white here, and nothing's changing. So why is there white? Why is this white stuck? It shouldn't be. That's not right. I should see it toggling black and white because I have no reason to draw that background because I already have the white, right? So there's a red flag right there. And now if you go deeper, so let's go to like one of our content rows here. So here's one of the here's like one of the whole cards, right? So you can kind of do the same thing. And okay, I'd at least expect this to be toggling, right? Because that's a background peeking through, and that's not toggling either. Okay, so that's broken. I'm definitely setting a background there I shouldn't. And this is kind of the way I do it. I just kind of go through it and say, okay, that should be toggling. That's not toggling. And a lot of times that's obvious. So like this one's working. See how it's toggling? So there's not an issue with that view. You can also, again, just go through and dive through. But sometimes it's not obvious. Should I be setting it here or not? And this is the easiest way to do it because if you toggle it and it has no effect, then you know you don't need to, right? So basically the fix to that is if when I looked into the code, you have, I don't know why it keeps opening that. You have this being set redundantly. So on the grid view, I'm setting a background, which I shouldn't be. On the image view, I'm setting a background when there's no need because it's already white, and I'm setting it on the frame layout too. So all 3 of those are bogus. There's no reason to set those. So again, to get rid of that, I'm just kind of cheating here so I don't have to type. Bam. So there goes the white. So if we run this again, and now remember what I said, dark red, never acceptable. Light red around text, okay. You know. So we're hoping to see maybe a little bit of red around the text, maybe better. So the spinner, that's fine, we don't really care. Open debut. Like I said, like loaded it twice, I might have clicked it twice.
Why don't you care about the spinner?
Because it's overlaid so many times anyway. And really, realistically, when you're trying to optimize these views, I, for the most part, only care about when you're scrolling. Like the static content's not as relevant, although it is possible to have like a fixed linear layout and have it so terrible it gives you a half second of jank. But that's kind of hard to cause.
The second time was good, though.
What's that?
You loaded the second time was good, though. You just loaded this one.
Yeah, so you see the difference, right? It was bright. Everything was dark red before, so we were at 4 times overdraw on everything. So now we look, and there's little touches of red. And let me go through it real quick to show you like how to visualize this, because this was a little confusing, right? Because it's like, well, why is this like strips green, and is that good, or can I fix that, right? So when you look at it, the very first pass is clear, and we don't see any clear, right? You see, second pass is you're getting a blue, so this image is a blue, right? And that's fine because it's on top of our white. That's our second pass, right? This is also blue because if you notice, the image actually clips out here. There's actually white space above and below it, so that's why this is blue and why this is blue. And now you get your third draw. This is just a black transparent translucency, right? So that would be a third draw. This would be a third here, but it's only the second up here, right? Because we didn't draw the image yet. And that's the reason this is the same color as well. And then after that, we're drawing the text. And one of the fascinating things about here is I can tell what wrap mode I used on the text view. I can tell I'm actually spanning the whole width because that being red when it doesn't truly need to be. So you can see the text there is your fourth draw, or I'm sorry, your third draw, third overdraw, which is why it's light red. So this looks decent. Your text is light red in places where it needs to be, right? Because right here you're drawing the white background, you're drawing the picture, you're drawing the text, and you're drawing that translucency background. So it has to be 4 draws. That's what it is. So but by looking at that, you can say, okay, I can't make that any better. And then you can move on. So does that make sense?
Can you scroll it so we can see if it's wide?
Yeah, it'll work the same way. But you just want to see if it's a little better.
Well, I guess it's doing all the stuff.
It is. That doesn't hurt performance though. So it's still pretty terrible, but it's definitely better. So you can see it's kind of good amount of jank still. So I'm going to turn this back off. And again, this is kind of the order I would do this stuff in. And I'm going to kill the app because I don't really trust it after you turn that on and off. So we kind of covered the 2 high-level topics here of reduced layout depth, reduced overdraw, and they sort of go hand in hand. You can kind of fix them together usually. And you use the same tools a little bit because you use hierarchy viewer for both of them. So the next kind of major thing is don't block the UI thread. And really the only way to analyze that is just to record the performance and see what's going on. So the way I do this is I don't like to confound things. So I don't want to be testing image loading at the same time I'm testing this other stuff. So I'm just going to like scroll, and I want the cache to be full, right? Because I don't want to be testing initial cache stuff because that's not really a steady state test. So, all right, so we got like a decent amount of stuff loaded. And what I'm going to do is just record scrolling for a little bit. You want to scroll and let maybe 1 or 2 rows load. And again, I don't want to test steady state. You want to be careful you're not testing your downloading code along with this. You want to kind of test that by itself because otherwise it gets so confounded with everything running at once. So what I want to do is, again, we're going to go back to this guy. And now instead we're going to go to DDMS. And this looks really similar in Eclipse. It's just in a slightly different spot. Find your guy. And you're going to hit this guy, which is the performance. Start method profiling, it's called. You can also trigger this in code if you want. I don't really use that terribly often. I usually just do it manually like this. So you click it once to start it, and then you can run. I think it only has about a 10-second buffer, so run for a little bit, come back, click it again, and I think it just overrides the buffer if you go too long. And also the times it gives you aren't real. They're grossly inflated, but they're proportional. So that's kind of the way to look at it. So hit record on that guy, and I'll come back here. I'm just going to scroll. I'm going to let like a row or 2 go. And it makes it a little worse. All right, so come back, hit stop. Another important note, don't be running with the debugger attached when you do this. It'll give you garbage results. So always do it with the kind of production version.
You didn't stop, you hit the stop?
Yeah, there's no stop. It's the same button you click twice.
What does the stop sign to the right of it do?
I don't know.
Stop processing.
No, that's not what you want.
Okay.
Yeah, so you hit it once to start it, once to stop it. I don't think this has like a. And this window is one where you need it like as wide as possible. So I think some of you are familiar with this. I don't think it has a zoom. No. Is it legible? Yeah, it's a little legible. All right. So I'll kind of go you through the process of how the heck I parse this, because it's just like an overwhelming amount of data. So this is easier with a scroll mouse. All right. All right. So the way to kind of look at this is at the top is all the threads that are currently running. And it shows you whenever there's like a line, that's when the thread's doing stuff. If you see like a giant gap in main like this, that's generally a bad thing. That's usually like super jank. Usually see it caused by the garbage collector, and you'll see in one of these other lines, you'll see a garbage collector running. And that kind of goes back to, again, to my fifth point of don't create garbage. And that's obviously unavoidable, but do it as little as possible. And a lot of times you will get to the point where it's optimized to the point where it's still janky, and the only thing you see is garbage, and you have to just rethink. Okay, are my images too high res, or I gotta cut down on the garbage. So kind of the way I start in here usually is I'll go to exclusive CPU time, and just start to look, just kind of for any outliers. That's usually where I start. So what you have in here, which is kind of cool, is you can sort by exclusives. So like 8.3% of the time was used on this thing, which is decode bitmap stream, which seems reasonable because we're processing a ton of bitmap data. It also tells you the number of calls, which is incredibly useful. So this was called 9 times. It gives you the CPU time and all that, but really this call time is really relevant. So you have to remember, like, what do we expect to have just happened? We expected getView to run maybe 6 times, 9 times, 3 times, somewhere in that ballpark, right? And getView is really what we're most interested on, because that's where we know with list views where all the work's done on the UI. So we look here, we see garbage collector ran a decent amount. That's not great. Maybe we can get that a little better. Draw list is running a lot. That makes sense because you're drawing. You should always see this draw stuff at the very top. So I'm just kind of looking for anything that outlies. Char list, full parse text is up kind of high. That's a little weird. Touch event, length of, motion events. These are all like OSy things. So when you get a lot of OSy things, it's generally okay. Response parsing, you kind of expect that to be up there because parsing text is hard. So nothing really jumping out at me except for this simple date parse text. And what's cool too is if you click on it, the part that it's like dotting on is the amount of time that's spent on it. So you can see on the main thread, it's I clicked off it again, but it was spending a decent amount of time on it. So that's one thing to kind of look into. In this case, we know it's the get view. And so the other path I'll go, so sorting that way, we found one thing that's a little weird. We might want to look into state parsing. If we go to sort by inclusive, this is kind of like your default view. You should see the OS taking like the first 20, 30 things, just with rendering and that sort of thing. So what I'll usually do is kind of scroll down this until I see the first thing that's in our namespace, and then start diving through there. I would expect it to be getView because that's where the work should be happening. So this all looks like OS stuff, Picasso stuff. And while this is taking a lot of time, it's not on the UI thread, so I don't really care. And you'd expect it to. It's downloading images and parsing them.
How can you tell it's not on the UI thread?
So you see the thread up here, main. And when I click on it, you see how it's underlining and kind of bouncing.
Okay.
That's where it's running on those places. So we can tell, okay, this is huge, but I don't need to deal with it. So that's how I would pass that.
Is there a way to exclude threads from the statistics?
No, not really. The tool's not It's not amazing. It has all the data there. It doesn't help you that much. You really kind of got to get the hang of it.
Can you use the find bar at the bottom?
I've never found a way to get it to be useful. I feel like it searches, but I don't know what it searches for or how to use it. I don't think it works. So again, I'm still kind of looking through here. This is still all a HTTP parsing stuff. I can't really help that. I didn't write it. Grid view, make row. That's all OSE stuff. Picasso stuff. Can't really help that. Decode stream. Expect that to be kind of hard. Grid view stuff. And somewhere around here, we're going to find our get view.
64 is the first one is yours.
Yeah, there we go. So, yeah, and this is the first one that's us, right? So you look at get view, and if you click on it, you can see, okay, so how bad is this relatively? It looks like it's doing a lot of work for chunks, like very continuous work, which on the UI thread can be a problem, right? You don't want to see big chunks running, because that means it's running that method that whole time, right? So if it's this wide, it's probably going to be an issue. And what you can see here is, so now we want to look like, do the numbers make sense? And this is where I mostly look at the call time. And how many times did it run? Does it make sense in my head of what I think it should be doing? And the first thing I kind of look at here is, okay, so inflate's taking 80% of the time. Can I fix inflate? That's my first thought. And I look at inflate and I see 6 out of 6. Well, that's weird because the cache was full. So inflate shouldn't be running. So that's the first thing that pops out. Does that make sense? So basically, now I'm going to go back to the code and I'm going to see, okay, something's wrong. So if you go to adapter, so you're going to go to your get view and try to see, so the pattern, view null, make the thing, get the tag, get the handle. Did I actually stick it in the tag? I did stick it in the tag, okay. So I mean, that looks reasonable. But this looks weird. That's probably not right. And in fact, it's not. And I've seen this pattern a few times. I've seen people more than once do instead of this if view equals null, they've done a if view is not, or they do if view equals null or get tag is not equal to my holder pattern, my holder class, right? Then make a new one because they didn't implement the cache correctly and it will only actually work some of the time. And what's really common I've seen is people, you'll override get count, but not get item view type. So you'll say I have a count of 2, but then your item view type is the default method, which always returns a value of 1, which means your cache will only ever hit half the time, but it'll think it's hitting and give you, you can actually cause it to give you either the wrong view, recycled view, or no recycled view, and it's actually really easy to do. So I've seen this probably on 3 different teams now where they've accidentally done this sort of thing, and this is exactly how I spotted it. Was you're like, okay, that's 6, that should have been 0. Let me start looking around.
You type count?
Yeah.
Oh, okay.
Yeah, so view type count in this case should be 1, which is the default. But in this case, this was a guy that implemented it and didn't know what it meant. So he's like, well, -1, I don't need that, which is a fairly reasonable thing, that's possible to happen. So I'm gonna fix this guy, and I think it's this guy. 168, yep. So
I've got a quick question.
yes.
Why have you created a new variable called view when you could just rename convert view to view?
I've always done that. There's not really a good reason. I think to me that's like a old school programming thing. I don't like touching the inputs because I don't want to modify them, even though that's not possible in Java. But there's no reason to. You don't have to. I've just always done it that way. So get revert. So okay, so I'm gonna revert this guy. So okay, cool. There goes our thing. So I always do this iteratively. I don't like trying to fix 2 things at once because.
Did you just take it out? Is that what
Yep. So it just deleted this thing, and I don't like to just say, okay, let me go back to my window and see what the next thing is because you never know what else it's going to affect. So I like to always do one run at a time. So So let that go, and I can close this and wait for that. Okay, so we got another one, and let's let it just pre-fill the cache again, so it's kind of apples to apples. So you can already see now we're already much better than we were. It's still not amazing, but it's not chopping for 2 seconds every time I do anything. So come back here, click on your deal, find your thing, click that, come back, scroll a little bit. I'm gonna let a couple cards load. Come back, click your stop button. Now we can already see the overall magnitude of this is a little smaller. And again, don't trust these entirely because they're not apples to apples. Just go for the ratios. Don't really trust the numbers. So if we come back here, we want to spot our get view again. It's probably somewhere down in this vicinity. Fill down, parse, measure.
It's a good sign. It's further down.
It is further down, yeah. And you'll notice that a lot. You'll notice like your number one error disappear to like 600, and it's just gone. Was it 101? Yeah, there we go. So it's not at all approximate, Travis. So okay, so we come in here, and now we just kind of repeat the process. And what I usually do is I just iteratively do this because you never know like when am I done, right? There's not really a good answer. The answer is do it iteratively, do one at a time, fix the biggest thing, see if the app's good enough, and if it is, you're done. And you just keep going because they kind of get exponentially harder as you go a lot of times, right? And you don't get as big a bang for a buck. So we just got like a huge bang for the buck for probably 20 minutes to totally find that and fix it. So the next thing in here, okay, is stream new, is a big hitter. It's running 4 times, which seems reasonable. I guess we should confirm that we actually fixed the other thing. So if you click this parent, that'll actually go back up. So now we see, okay, total calls to this guy was 4. And I don't see inflate being called at all, which is correct because we had our cache full, right? So I'm going to say, okay, let's fix this stream new thing. So I don't know what's wrong with it yet, but you can go into it and let's see what the heck is it doing. Okay, 98% of the time it's creating a date object. So fun fact, creating date objects is really slow. So I'm going to go back to this new method and say, okay, well, I probably shouldn't be making this date object. So we come in here and we see current time is new date.getTime. First, that's a naive solution because you can just get the system time, which is much less heavy, and that's all we want anyway. We're just making a date object and getting the millisecond count anyway. So that's not needed. Looks like we're also here taking the stream data we're getting from them and parsing that into a data object, and then we're doing the number math. So this is wrong for a few reasons. The first is you don't want to be making this. There's no reason to ever make that. And this one, you really don't want to be parsing it on your UI like this. There's no reason to do it while we're scrolling, parsing a date and making a date object, which is extra garbage and it's really slow to make. So the solution in this case is move this up when the API data first comes back, parse this, do the number comparing, and then just set a flag. It is new flag, right? So that's what I did here. So basically, I moved all this stuff, and this is we're looking at the opposite commit here, basically. So basically, I added a stream as new flag. I moved all this stuff up to the top level, and instead of doing that, I do the system.current time in milliseconds, which is a lot less heavy. There's no reason for that data object in the first place. And I do my comparison up there once and set the flags, right? So undo that guy. Oh, did I touch a file? Probably did. What are you doing? Merged. You got screwed up, didn't you? All right. No, other one. Oh, okay. It had a merge conflict on the deal. So. I don't feel like stun coding this. I'm just going to revert it. You can't report a merge, can you? Just do it this way. Huh? All right. I'll just skip that one. But you get the idea with that one. So fix that. Come back in. And you want to see what's the kind of next thing going on. So come back in here. We see stream new. So let's say we just fix that. Set text is actually kind of slow. Something worth knowing. So you really don't want to be calling it more than you have to. Like, don't call it 3 times in a row, even if you're not going to render it until it's, you know what I mean? Like on the same run method. Picasso is kind of slow. That's sort of expected. It's doing a lot of stuff, a lot of queuing. So the next heaviest hitter one here is this strings.matches, which isn't huge, but if we're still not performing enough, I would keep going. You know, just keep working down the list on stuff you can hit. And again, you can't fix all of them. Like that Picasso one's a big chunk, but we don't have access to that, right? So this string one kind of pops out to me. And so string.match is inside of getView, which is up here. So, oh, here's a matches. Okay, so there's a matches. So I guess that's how I'm showing that that little gaming icon, right? As I'm doing a matches comparison. So at first glance, you'd say, okay, this is fine, right? Why does that matter? And in this case, it's not a huge hitter. But if you look here, string.matches is actually doing a regex pattern match compile, which can be very, very slow. This happens to be a pretty simple match. It's just the word gaming in lowercase. So in this case, we don't even need that. We can just do a dot equals or equals ignore case or something like that. But what I'm trying to point out here, and I've seen this mistake too, is a lot of times you'll have a fairly complex pattern here, and it's actually going to compile it in your UI when you're scrolling. And it can be quite slow, like maybe 15, 20, 30% of your processor, of that method's processor time. So what you want to do instead is if you have something like this where it's a fixed string, do your pattern compile like in your constructor for this class, and then just pass it in here. You still have to make a new matcher, but you can reuse the pattern. And the pattern compiles the slow part. So that's kind of the takeaway on that. So get rid of that guy.
In that instance, would you recommend pattern matching rather than creating like an enumeration or something when you first pass the data like you did with it's new?
That would probably even be a better solution. Yeah, do all your work up front. And in that case, you don't even have to leave the... or does it skip the reverts from Ellen? I guess it's being stupid. But in that case, you wouldn't even have to leave the UI thread because you're already showing a loading spinner. And realistically, you're talking adding maybe 200 or 300 milliseconds here. So just leave the loading spinner spin and just do your heavy work right there. You know, there's no need to get fancy with it.
The user's not going to notice.
No, they're not going to notice. So So in this case, we can just do an equals. And again, there's your 3 approaches, right? I guess the only time you'd really have to is if you expect the data to be updated on the fly, or I don't know. Yeah, there's kind of a trade-off. So there's another one that's kind of bad. If we go back to, and I don't want to keep recompiling just for speed here, but in the real world here, I would probably rerun this every time because it just gives you a better reading. So okay, so we're back in GetView. So what else is bad here? Matches, append, get channel, strings, visibility. To matches, Picasso load, append, string builder, data. So this guy's actually, my image is too low res for it to show up very well, I think. But one of the other issues in here is, and if you had a higher res image, so in this case I'm loading this guy. And so say this was like a bigger image, which is kind of common, like talking to like our kayak or Travelocity thing yesterday. Like say you had like a big picture of a car that's like the whole screen or something, and it's in your resources file, and you're just loading that in code because you want to, say the API is telling you which background to use or something, right? So that's kind of like a fairly common use case. Another mistake I've seen pretty often, and it'll cause a good amount of jank if it's in a scroll view, is loading the, let me see where I find it, resources here. So it's this gamepad row again. So I'm setting this gamepad drawable here, and in this case, again, it's small. But I'm just got the image, and I'm just calling, so ImageView.setImageResource, which you're saying, okay, fine, right? That's what it's for. It takes a drawable ID, and it loads it, and right? But, I mean, if you just think about it logically, it's going to take that drawable, and it's going to do just what Picasso's doing. It's going to take it, it's going to read it from disk into memory, create a large bitmap object, and then set it. You shouldn't be doing that on the UI thread. You know that, right? We know that from loading bitmaps normally. So even for something like this, you want to use Picasso and not load it in line like this. So, and Picasso supports that. It's just load, and you just put the drawable right in there. So does that make sense? And that's really overlooked a lot. I don't think a lot of people realize that's a thing. But if you try it on a big image, it'll jump out at you pretty quickly. So I guess the only other one to talk about, and this one's a little harder to spot. So we knew we had a lot of garbage, right? Because we saw that was taking kind of big chunks. And just kind of looking at this, the images overall just seem extremely crisp, maybe too much so. And when you're looking for garbage, the first thing you want to look at is, are my images too high res? Since you're using Picasso, you don't have to worry about doing bad things when you're making them. So basically, like in this case, after looking at it, I can see, okay, here's where I'm loading my images. I'm doing these get huge, which is probably not right. So kind of look at it again, and this is where you just kind of a little bit guess and check. This API gives us 4 sizes. Turns out huge is way bigger than we need. Mediums actually looks just fine and causes probably a quarter of the garbage. So kind of the last step here for me was just getting that back to normal. So I'm going to just kind of cheat here. So, okay, so I switched those both to medium. I fixed some of the other stuff we were talking about. So I fixed this to contains gaming, a little safer than equals, a little more work, but a hell of a lot quicker than a regex compile. And in this case, I would say this is fine, James, because an equals comparison is not terribly heavy hitting. But again, it would be better to move it up. But you'll get more bang for the buck with other stuff probably. The date stuff you definitely want to move up. That's not safe to be down here. And it's also using Picasso to load the thing. Fix the view holder pattern, so everything's good. And again, when we first looked at this, it looked fine. You know, it didn't really look like it had issues, but as you start running through the tools, they just sort of jump out at you. So let's let this run. So you see the image is loaded way quicker, and they weren't cached either because we just changed the sizes, right? So it's loading quicker. Still getting a little bit of stutter, but that's because I'm on this simulator. But it seems fairly reasonable for the simulator at this point, right? And again, I'd probably use a real phone if I was not demoing this. It's a little more real, right? Because it doesn't get these performance janks because it's the tester. So at this point, I mean, when we started this, you couldn't even scroll at all. Now it's working pretty good. So yeah, the only other thing, yeah, I'll cover this last one. Okay, so let me do one more. If I go to the recorder, this is a common issue I've seen probably, I don't know, 100 times at different teams now, including ours. If we go to record, and I want to get this kind of page down a little bit. In fact, I want to restart it. So this is something I recommend testing, is when you have infinite paging, always test your edge case, because I've seen way too many issues with edge case that's not done right. So in that case, this is going to be hard to record, so I'll just talk through it. But in this case, and this is what I've seen several times, so what we're going to do is get close to your edge. Probably what you want to do for testing purposes is just, right now it's auto-downloading when there's 10 left. I'd probably set it to 0, and maybe put like a overlay on your second to last image or something so you can see it coming. Just real quick hack it in to test it. In this case, when you're scrolling, it's actually going to try to download the API again for every pixel you scroll after it kicks off that initial pixel, which is actually really common to do when you're doing the scroll callback stuff, because you're basically saying like, okay, when I'm down to my last 4, kick off the API request. And that callback's on scrolls. Every time you move a pixel, it's going to call back. So it's actually really common for you to either call your API and queue up about 100 requests simultaneously, and then when they come back, take all 100 results and stack them, or to throw out the rest of the 99 and only keep the first one. Or it's common, yeah, so that's really common to have happen. And if you're throwing out the other 99, you may never spot that. But you're going to hammer your API. You're essentially denial of servicing your own API, and the performance you won't know. But all of a sudden, you'll be scrolling, and it'll just get terrible for 30 seconds, and you'll be wondering like, why does it get terrible when I load the next page? And that's usually what it is. So that's something to be wary of, and I would definitely test it whenever you write any new paging stuff. So, yeah. All right, I think that's the gist of it. So that's kind of how I would go about just taking an application that you don't know or that you wrote. Like if I write a new feature, this is the process I follow. And I don't bother optimizing in the beginning. I don't believe in optimizing as you write because I think it's impossible. You never know what the bottlenecks are until you test them and see what they are. Obviously, don't write things that are terrible, right? But I wouldn't try to add caches before you measure it and see that you need one, because I think you're just adding complexity. So I think that's it. So any questions on any of the tools?
So when you're testing, when you optimize as you're writing it, do you think there's any value in making for the scrollable list a base case of one item, and just kind of checking it out with that, or do you think that's not helpful since it's not something situation?
Base case, just to like see.
So your data isn't.
It's like if you're gonna have 3 different things in your list, like 3 different row types, then.
Yeah, so like you just populate one item, that way your hierarchy viewers.
Oh, I got you. You could. The problem is generally, it has to be running code, right?
Yeah.
So you're gonna have a hell of a time timing when the screen first opens.
You can just tell your app to stop.
No, but what I'm saying is there's no way. It's hard to time that, right? Because you need to be able to click that start button and stop button. You can do it in code. So like in code, you could add a start profiling right when you like hit the download and when it comes back. Although I think that's more effort than it's worth. Like I think you can just do it. Like I would definitely test the cache empty case and the cache full case, like I did here. I didn't bother to test the cache empty case because I know it's not an issue, but because I'm using Picasso, if you're not, it's probably likely an issue. But I would definitely test that. I would test cache empty, cache full, and I would test page loading, like right when it's crossing over, and test them separately, right? You don't want to test your page scrolling until you've optimized those other two first, because it'll be such a mess you won't be able to tell what's going wrong.
Cool. Anybody else? Great. Thank you.
Yep. So if you're looking to learn more on this topic, here's a list of helpful references. The first one is from Roman Guy. It's a post a few years old where he walked through a similar process on an application that he came into. The second one's a fairly new post by one of the, or more of the developers at Venmo. And the final reference here is a link to my open source project, which you can use to learn, but I also encourage you to try to just get it from scratch and try to go through and fix this yourself and see if you can do it. And the answers are on the bugs branch.